We are going to begin our review of exponent laws by applying them to different expressions. Our goal in this is to simplify the expression as much as possible, following the order of operations. For example, this example here includes an exponent outside of a bracket. As a first step, we need to apply that exponent to everything inside the bracket. Just to make this really clear, we're going to do this step by step. So including the constant at the front, -4, that also has that same exponent applied to it. Then we have a to the power of -5 to the power of -2, and b cubed to the power of -2. I'm also going to write out the rest of this expression, just so we don't lose anything. A to the power of -1, b squared. And I'm just going to do whatever I can to simplify the top of this. -4 to the power of -2, I'm actually going to bring that down into the bottom. And it will be -4 squared, giving it a positive exponent. Now, for the next one, take a look at those exponents. When we multiply -5 and -2, that's actually going to give us a positive exponent. So that will give us a to the power of 10 on top. We'll also have b to the power of -6 on top, and I would probably move that to the bottom, but I'll do that in the next step. We have a to the power of -1 and b to the power of 2. Okay. At this point, if you would like to rearrange for positive exponents, you can, or if you would like to combine your exponents first, you can do that. We have a to the power of 10 minus -1, b to the power of -6 minus 2, over -4 squared is 16. Now that's going to be a to the power of 11. It's going to be b to the power of -8, so I'm going to write that in the denominator and give it a positive exponent, and I'm going to put that 16 in front. So we have a to the power of 11 over 16 b to the power of 8. Done. When we're simplifying, we always make sure that we end up with positive exponents, so try and get in that habit. Now, to look at a slightly different application, can we simplify if we don't have a common base? As this example stands, we have a base of 4 and a base of 8. Because those are not a common base, we can't apply any exponent laws yet. So our first goal would be, is there a way we can rearrange this expression? Now, as a matter of fact, 4 is equal to 2 squared, and 8 is equal to 2 cubed. So we can actually rewrite this expression using a base of 2. That would be 2 squared to the power of 2x times 2 cubed to the power of 3 minus x. Now that we've rewritten this, why don't you pause the video and try and simplify. Come back when you're ready for a solution. And here we go. So by rearranging using the same base, we can see that we can then apply the exponent laws and simplify down to a single expression. See if you can do something similar for example 3. So for example 3, the bases we have right now are 9, 3, and 27. Can you find a common base for those three numbers and rewrite it in the same way? Pause the video again and come back when you're ready to work this through. All right, let's try this one together. 9 is 3 squared to the power of x minus 3 to another power of 3 times 3 to the power of 2x all over, instead of 27, we'll do 3 cubed to the power of x minus 5. The first part I probably want to deal with is that exponent to the power of an exponent to the power of another exponent, and just multiply those together. You can do that in one step or in multiple steps. I'm just going to do 2 times 3 and then multiply by the x minus 3. So that can be 3 to the power of 6 times x minus 3 times 3 to the power of 2x over 3 to the power of 3x minus 15. And again, whatever we can do to make that a little simpler, 3 to the power of 6x minus 18 times 3 to the power of 2x over 3 to the power of 3x minus 15. Okay, we're now at a point where we can start adding and subtracting. So I'm going to rewrite this with one base and just a really long exponent. 3 to the power of 6x minus 18 plus 2x minus 3x minus 15. Watch that bracket on the last one and make sure you're subtracting the whole thing. So we have 3 to the power of 6x plus 2x minus 3x. That will be 5x. And then negative 18 and minus negative 15. So negative 18 plus 15, or minus 3. That gives us 3 to the power of 5x minus 3. All right, next one. Similar concept for this one. This time our bases are 27, 9, and 1/3. So the difference here is 1/3, and again we just need that little reminder that 1/3 is the same as 3 to the power of negative 1. So keeping that in mind, see if you can solve this one. Pause the video and then come back to check your solution. And here we go. Pause this if you need to keep the solution, and then let's go on to our next example. Now this last one is mostly a reminder that we can't always jump into the exponent laws. So in this case, there's a couple of things I noticed. One is that we have different bases like 3x, 2, 6. But the other thing I noticed is that I also have addition. So even if I did have the same base in the numerator or the denominator, I can't necessarily start with an exponent law. So I need to look at what my other options are. What I do notice in this problem is I have 2 to the power of 4x and 2 to the power of 4x in both terms in the numerator. So that's something I could actually factor out. In the denominator, I have an x squared and an x, so that also factors a little bit. So I should start by maybe trying to factor the top and the bottom, and let's see if there's anything that will reduce out or if anything becomes a little more convenient when we do this. So starting with the top, I can factor out 2 to the power of 4x. I'm also noticing there's a 3 and a 6, so I'll be able to factor with those as well, but I'm going to take this in a couple of steps. If I factor out 2 to the power of 4x, then in brackets I will have 3x to the power of 5 plus 6x to the power of 4. So I can definitely factor 3 out of that and also an x to the power of 4. I'll save that for the next step. In the denominator we have x squared plus 2x, so let's just factor out an x, and that leaves us with x plus 2. Let's keep factoring our numerator, so 2 to the power of 4x times 3 times x to the power of 4. And if we factor that out, then we are left with x plus 2. That is really convenient. I think we can see where this is going. And in the denominator, x plus 2. So we can reduce some things. If we were to do x plus 2 divided by x plus 2, those divide to 1. Similarly, I have an x, and I have an x to the power of 4, so I can divide out a single x and make that x to the power of 3. Let's rewrite that. 2 to the power of 4x times 3x cubed. I've actually divided out my entire denominator, and it's just 1, so I probably don't need that. So our final answer at this point is 2 to the power of 4x times 3x cubed. And it may be tempting to now try and use some kind of an exponent law, but notice again we have different bases. There's not much else we can do to combine. We can't even multiply our constants because one of them is being raised to a power. So this is actually our final answer and as simplified as we can get it.